Okay, this is project test 8, video number 1, and it'll be problems 1 to 10. A group of students played a game in which they earned points for answering questions correctly. The following dot plot shows the total number of points earned by each student. Which of the following is the best description of points earned? All right, so when I look at this, I go, you know what? I have two different clusters or two different centers. This is obviously two different peaks. So I'm thinking this is bimodal. I also notice I have what looks like outliers over here or a gap. So I either have outliers or a gap. Now, if I were writing this up on an FRQ, I would describe where my centers are, and I would give the range of the overall data, and I would say where my gaps are, etc. So approximately normal, no, this is not mound shape. Bimodal without a gap, no, it's bimodal, but we definitely have a gap because we have no data within this area right here. Bimodal with a gap, I'm liking this a lot. Skewed to the right would be like this. And so it's definitely not skewed to the right, and that gets rid of these two. So our best choice is for number 1 is C. Moving on to number 2. The table shows responses from 103 people when asked if they support a proposal to expand the public library. One person from those who responded will be selected at random. So we're going to select randomly from here. Which of the following is closest to the probability that the person will be someone who responded no? So we're looking for responded no, given that the person selected was 55 or older. So we have the given of 55 or older, and given is always in the denominator. So 55 or older, that does not look much like an older. And the intersection will be in the numerator. So 55 or older, that's our given, that's what's in the denominator. And we wanted responded no. And the intersection of responded no is going to be 36 over 44. And if we take 36 and divide it by 44, we end up getting 0.818. So for number 2, our best answer is E. All right. Please remember, given is always in the denominator, and the intersection is in the numerator. Number 3, data were collected on the fiber diameter and the fleece weight of wool taken from a sample of 20 sheep. The data is shown in the following graphs. Graph 1 is a scatter plot of fleece weight versus fiber diameter with the respective least squares regression line. Graph 2 is the associated plot of the residual. So here's our residual plot, and here's our linear regression plot. 1 point is circled on the graph. 5 points are labeled A, B, C, D, and E are identified on graph 2. Which point on graph 2 represents the residual for the circle on graph 1? Well, remember, residual equals observed minus expected. Okay, so we have this plot right here, this dot right here, and this is what we observed. And we observed a 5, and this line is our predicted line. And if I draw a dash over here, it looks like it's about a 10. So 5 minus 10 gives me a residual of -5. So I'm going to look for a point that's approximately -5. And if I come across here, -5 and at a weight of 10 is right here at C. All right, because this is our fleece weight, which is at 10. So that tells me I need to be one of these 2 points. And like I said, observed minus expected gives me a residual of -5. So the only residual that's close is C. Okay. Make sure you pay attention to the titles. They give you a hint. Fleece weight, oh, fleece weight, 10 and 10. So we have to be one of those two. And once again, using the residual formula. Number 4, the distributions of 4 variables are shown in the histograms below. All right. Which of the following shapes is not represented by one of the 4 distributions? So when I look at this, it's like, you know what? I have 2 peaks. I'm going to assume that this is bimodal. And sure enough, bimodal is listed. So, and they want not represented. When I look at this, this has obviously been stretched to the right. So this makes this skewed right. And we definitely have skewed right as a listed possibility, so we can scratch that one off. This one here, stretched to the left, so that makes it skewed left. And by the way, skewed right, that means our mean is bigger than our median. Our mean will be bigger than our median because our mean is to the right of the median. Skewed left means mean to the left of the median. To the left of the median. And one other thing that we can say about this, the mean will be less than the median. Okay, so we've gotten rid of skewed left. And then I look at this last thing, and I certainly don't know if it's normal or not, but it's definitely mound shape. It's definitely symmetric. And I only have one mode. And because it's symmetric, the mean will equal the median. And that is always the case for symmetric data. All right, so they happen to have symmetric and unimodal. So the one that's not listed is uniform. And just as a reminder, uniform is going to look something like this. Everything is going to be about the same height. Okay, so that would be a unimodal, and we did not have anything that everything was about the same height. Okay, number 5. A random sample of 1,092 people were asked whether color was a consideration in buying a new car. They were also asked to identify one additional feature that was important. The responses are shown in the table. Which of the following is closest to the proportion of people who responded no to color consideration and who identified safety as an additional feature that was important? Now notice, there's nothing that says given. There is no condition. All right. Since we have no condition, our denominator is going to be the total amount. Because there was no condition, our denominator is going to be the total amount. And what we're interested in is no to color and who identified. So no to color, and that tells me my intersection. So my intersection over my total. So color, 534, but, and who identified safety. So in this case, we have my intersection is 192, and the total is 1,092. 192 divided by 1,092 equals 0.1758. Our closest answer, even though it's not exact, is A, which is 18%. Okay, so that's number 5. Number 6, Scientists estimate that the distribution of the lifespan of the Galapagos Island tortoise is approximately normal with a mean of 100 years. And a standard deviation of 15. Based on the estimate, which is the following is closest to the age of a Galapagos Island tortoise at the 90th percentile? So they're telling us this area back here, the shaded area, is 0.90, and we're looking for x. So I'm going to go ahead and set up my z formula. Z equals x minus mu over sigma. And I'm going to start plugging in what I know. Well, we know we don't know x, but we know our mean is 100 years, and my standard deviation is 15. So can I get a z? And the answer is yes, I can. Because they told us it was normal, I can use the inverse norm to get the z-score. So second vars, inverse norm, area is 0.90 because it's a percentile, mean is 0, standard deviation 1. And we end up getting 1.28. Now, there's actually more than one way to do this on a calculator, but I really want you to get used to setting up like this. I'm going to multiply times 15, and then I'm going to add 100 to it. And I end up getting 119.22 years. My closest answer for this is C. So X equals 119.22. And once again, there's other ways to do this on a calculator, but if you were doing an FRQ, you would need to show it like this. Number 7, a car agency has 2 locations in a city. The box plot below summarizes the miles driven for one day of single car rentals at each location. All right, so what we have is we have a spread, more spread out and less spread out, but both of them have outliers and both of them are stretched to the right, which means they're both skewed to the right. All right, so let's see what we have. The number of single day rentals is greater for location A than for location B. We have no idea how many, so we can't talk about the number of single day rentals. The number of single day rentals is less for location. Once again, we don't know how many are in location A and location B. They didn't give us that information. Compared with location A, the miles driven for location B display more variability. Yep, it's definitely more spread out. So more spread out, the more spread out you have, the more variability. More variability is more spread out. And the median is greater. And sure enough, this is the median of B and this is the median of A. The median of B is definitely greater than the median of A. So the best answer for 7 is C. Moving on to number 8. For the purpose of determining the value of its end of the year inventory, a clothing store creates a list at the end of the year of every item currently in stock. So they have a list of every item with each item's price. Which of the following is the best description of the end of the year activity? First off, there's no treatments assigned, so this is definitely not an experiment. So A and B are definitely not possibilities. A sample survey, maybe. Okay, technically this is a census because we collected every item. So let's keep going and see if they have something better than a sample survey. All right, and sure enough, as we keep reading, we see a census because the wholesale items prices of all items. And remember, a census is a survey of all items. So it's a list of all the items. So our best answer is 8, or 8 is E. For number 9, a grocery store receives deliveries of corn from 2 farms, one in Iowa and the other in Ohio. Both farms produce ears of corn with a mean of 1.26. I'm going to go ahead and make a little table here. Iowa, Ohio, and this has a mean equals of 126. or 1.26, and this has a mean equal to 1.26. The standard deviation of the weights of the ear of corn from Ohio is 0.01 pound greater than from Iowa. So I don't know anything about the Iowa one, but I know the Ohio one is equal to the Iowa standard deviation plus 0.01. And I'll come back to that in a moment. A randomly selected ear of corn from the weight of Iowa from Iowa weighed 1.39. So we have an X equal to 1.39. And it has a standardized score. Whenever they say the phrase standardized score, this means we have a Z-score. And so in this case, our Z equals 1.645 for the distribution of weights of the Iowa corn. If an ear of corn from Ohio weighs 1.39, so X equals 1.39, how many standard deviations from the mean is the weight? So we're looking for the Z-score, because they want to know how many standard deviations, and that is the Z-score. So that's what we're looking for. Well, obviously we have this information, so maybe we can get somewhere with the Z-score formula. Well, our Z-score formula is Z equals X minus mu over sigma. And so when I'm working with Iowa, I happen to have 1.39 minus 1.26. I don't know the standard deviation, but I have a Z-score of 1.645. So if I rearrange this with a little bit of algebra, 1.39 minus the 1.26, and I divide that by 1.645, I end up getting a standard deviation of about 0.079. So the standard deviation for Iowa, so this standard deviation equals 0.079, and that's what we just calculated right here. Well, I know that the Ohio one is Iowa plus 0.01, so that means standard deviation is 0.079 plus 0.01, which means the standard deviation for Ohio is 0.089. So now that I have that, I can probably calculate my Z-score, because once again, Z equals X minus mu over sigma. Let's plug in. Well, we have a 1.39 minus a 1.26, and we're dividing by 0.089. 1.39 minus the 1.26, and I divide by 0.089, and I get a Z-score of about 1.46 standard deviations. Now the question is this positive or negative? Well, first off, because it's positive, that means we are above the mean. There's also another hint that we're above the mean. The other hint is our X is above the mean, and if our X is above the mean, we're definitely above the mean. Now, one thing we don't know about this is we could not use the normal. We cannot use the normal. We cannot use the empirical rule because we don't know that it's normal. But we can always use Z-scores regardless of the shape to make comparisons. So our best answer to this one happens to be B. All right, moving on. The distribution of the number of hours worked by volunteers last year at a large hospital is approximately normal, with a mean of 80 and a standard deviation of 7. So they're telling us it's normal. So I'm going to go ahead and draw this up. A mean of 80 and a standard deviation of 7. Volunteers in the top 20%, so that means these group up here, and we don't know what that value is, will receive a certificate of merit. The volunteer from last year is selected at random. Which of the following is closest to the probability that the volunteer selected will receive a certificate of merit given the number of hours the volunteer worked is less than 90? So I'm going to draw another graph. And it's going to have the same mean at 80. But we want to know if they worked less than 90. So if this is less than 90, what's the probability they received an award? So basically we're saying this, given that they worked, so remember when we work with given, it's intersection over given. So that's not an N, that's supposed to be an intersection sign. So basically the probability that X is less than 90, and then the numerator is going to be the intersection, which means they have to work greater than X. So this intersection right here, and we don't know what that is yet. But let's find out the denominator first. Well, the denominator is going to be the probability that X is less than 90. And remember, Z equals X minus mu over sigma. And when I plug into that, I'm going to have 90 minus 80 over 7. So second vars, normal CDF, lower bound is negative infinity, so negative 99999. Upper bound, upper part of my shaded is 90. Mean is 80. And the standard deviation is 7. And it tells me that this probability is 0.9234. That's how much area. So that's what's going in my denominator, is 0.9234. But I need to know the likelihood, where does someone get an award? Well, they get an award if they make over X. Well, what is X? So I've got to calculate that value right there. What is that value? So 0.20, now remember our calculator works from left to right. So this area right here happens to be 1 minus 0.20, which is 0.80. So I'm going to do an inverse norm of 0.80 to get the z-score. Second vars, inverse norm, 0.80. So I get a z-score of 0.8416. So remember, z equals x minus mu over sigma. We're looking for that x value. And we have 0.8416 equals x minus 80 over 7. So I'm going to solve for that x times 7, add 80 to it, plus 80. And basically, someone had to work more than 85.89 hours to get an award. So that's the group that got the award. Now, I'm looking for, ultimately, and I'll try to fit in that 85.89 right here. I want this area. I want the intersection, the probability that 85.89 is less than X is less than 90. That's what I'm looking for. So this ends up being my lower bound. This ends up being my upper bound. We're going to do a normal CDF, second vars, normal CDF, lower bound, 85.89, upper bound, 90, mean is 80, standard deviation is 7. And we end up getting that this area right here is 0.1234. I divide that by 0.9234 because that was what we have in the denominator. and I end up getting 0.1337. And my closest answer to that is 0.134. So 10 is C. All right, very important that you do the given part, which is, hey, what's the probability that they work less than 90? Less than 90 had this 0.9234. That was our denominator. It goes here. Then we needed to calculate the probability, what value you got to actually win an award. And to win an award, you had to work more than 85.9 hours. So we want to the intersection in the numerator, because it's always intersection over given. So 85.9 to 90 over the probability that it was less than 90. All right, that closes out this video.